Okay, so today we are looking at inverse functions. So what is an inverse function? So let's consider a graph. Y is x plus 2. Okay, we did sketch this graph in the previous session, so let's just do it quickly. Nope. Okay, so let's give it another try. Yay. Okay, okay. And then we can 8. Okay. That straight line like that. And then another one that nope. Let's do it like that. Okay. So you know that that's y and then that is x. Okay, so when we sketch, we know that we need 2 points, the y-intercept, which will be there, and then the x-intercept, which will be over here. Okay, so this is x is minus 2, and then this is y is 2. So this is our graph. Okay. Our graph, our graph. Okay. Another line that we must be familiar with is this line. Yeah, no. Okay. Is the line that passes the origin of the Cartesian plane. Uh, uh, my technology is playing games today. Let's see. Mm, ah, let's try it for the last time. Let's see. Okay, let's give it another shot. Much better. Okay, so there's this line that passes the origin of our Cartesian plane. Now, the equation for this line is y is equal to x. So it's a straight line. It has an equation of y is equal to x. Now, this is the function. Okay, this is the function, the straight line. Okay, and we saw in our previous session that this guy is a one-to-one function. We explained all of that in the previous session. So if I take this guy, this function that we have, and I flip him, I take this guy and I flip him to the other side, what will I get? I would get a straight line that is something like this. Okay, I'll get a straight line which is something like that. Now, that straight line that I obtain, or that graph that I get, is what we call an inverse function. So an inverse function is the graph that you get when you take the function and you reflect the function over the line y is equal to x. Okay, so that's the case. Okay, so that is the geometric way of thinking about this thing of a inverse function. But then now, what if we want to like do it in a formal manner? How do we move from a graph to an inverse function or to an inverse graph? Now, that one is very simple. We simply look at the points that we have on that graph, and then look at the points that we have in that graph. We have this point which is negative 2 and 0, and then we have that point which is 0 and 2. Now these points belongs to the function. Okay, let's see, we could see how we're going to move from here to an inverse function. Okay, so this one will be for the inverse function. Basically what we do, we swap the coordinates. Okay, so this point will be 0 and minus 2, and then this guy will be 2 and 0, and that will be it. So these 2 points are the points that we can use to plot the function of the inverse or the inverse function. Okay, so that is the case. Okay, so we see that this point is actually x is equal to 2 and y 0. We see that that point, this one, is actually x is 0 and y is minus 2 from there and there. Okay, so basically this point is that point, is this one. It's this one, and when it comes this side, it is flipped, or it is swapped. The coordinate swaps, and then it becomes that one. Okay, this point becomes that point, and so forth and so forth. But then the main idea is that an inverse function is a function that we get if we take the graph of the function and we throw it over the line y is equal to x. Whatever that we get on the other side of that line is the inverse function or the inverse graph. Okay, so that's the idea behind this thing of inverse functions. Okay, now what if they want me to determine the equation of an inverse function? So if I'm given the equation of the function and then they want me to determine the equation of the inverse function, very simple as well. Okay, let's do that. The equation of the function that they gave us is y is x plus 2, right? So to determine the equation of the inverse function, number one, we have to swap the the variables. So the x will become the y will become the x. So to get the equation of an inverse function, what do we need to do? Number one, we need to swap x and y, swap x and y, swap x and y. And number two, we need to make y the subject of the formula. And then after that, we know that that particular equation is the equation of the inverse function. So number one, we swap x and y, and then number two, we make y subject, the subject of the equation, the subject. Okay. So let's put that into practice. So for this example that we have, we will make we will swap first, so it will be x is equal to y plus 3 plus 2, I mean, and then we will make y the subject of our formula. So we will take 2 to the other side, so we'll have x minus 2 is y. Okay, so we can write it like this: y is x minus 2, right? So this guy is the equation of the inverse function of that guy, of this one. Okay, so in other words, this equation is the equation for that graph. Okay, y is equal to x minus 2. And we can tell from the graph as well that we have the y-intercept at minus 2, the x-intercept at x is equal to 2, and so forth and so forth. Okay, so this is the situation. Okay, that is how we determine the equation of the inverse function if we are given the equation of the function. Okay, now very important. The theme that has been coming up over and over again is that in order for us to change from this thing from a function to a inverse to the inverse function, we just need to swap the x and the y's around, right? So that can be extended. We can say that the because of that swap, the domain of the function will become the range of the inverse, and the range of the function will become the domain of the inverse because of the swapping around. Okay, so we can say that one thing that we see is that the range of an inverse function, okay, of an inverse function of an inverse function is the domain. Let me just write it like this: the range, of the function. Okay, let me just phrase it like this: the range of the function becomes the domain of the inverse. Okay, becomes the domain of the inverse function. Okay, and the reverse is true. That's the domain of the function. Domain of the function becomes the range of the inverse. Range of the inverse function. Okay, that is what happens. Okay, and yeah, so that is what we need to understand. And last but not least, you will recall that in our previous sessions, we spoke about the different relationships that we have, like the different functions that we have. So we have two types of functions. Remember, there's one-to-one function, which is an example of a straight line. So straight line is a one-to-one function, and exponential function is a one-to-one function as well. And then there is another type of function which we call a one, which we call a many to one function. I nearly said one to many. We call that a many to one function. So that is an example of parabolas and stuff and stuff. I think in a hyperbola as well, if I'm not mistaken. Maybe I am wrong by that. I think so. I'm not sure about that part, but then I think a hyperbola as well has a relationship of many is to one. So that is another example of a function. And then we saw that there is a situation whereby they are a sharing of. Okay, so we will recall that we spoke about the different relationships that are associated with graphs, right? So we said that there's one to one, there's one to many, there's many to one, and so forth and so forth. And then we concluded that if a graph has a relationship of one is to one, for example, it's a straight line graph, it's a exponential graph, and so forth and so forth, those type of graphs, they are functions. Okay, and then if a particular graph has a relationship of many to one, that graph is a function. Okay, so if we have one to one or many to one, then we know that we are dealing with the function. But then if we are in a situation whereby we have one to many or many to many, then they those two scenarios we are not dealing with functions, because remember, a function is a graph whereby every y value has their unique x value. So in other words, in order for a graph to be a function, there must not be any sharing of x values. Okay, there is no sharing of x values. Every y value has its own x value. Okay, so if we take these ideas and we associate them with inverse functions. Now, the the question becomes, or the question should become, okay, now we have a function, okay, how do we know if the inverse will be a function or it won't be a function? Hopefully that question makes sense. I'm saying that we have we have a graph like this. Um, we have a graph, and here, this is the graph that I'm talking about. This one. So we have a graph. Now, if I take this graph and then I reflect it over, or I flip it over this line, the line y is equal to x, how do I know whether the graph that I will get will be a function or it won't be a function? Okay, so that one is very simple as well, because we simply flip or we simply swap. Okay, so we know before even the swapping happens that um, that graph, we know that this graph, this one, has a 1 to 1 relationship. Okay, 1 to 1 relationship. It's a straight line. We know that one. So this is a function because there is 1 to 1. Okay, now we know that this is the x in relation to the y. So every 1x value in this case is associated or linked to one y value. Okay, now remember, when we are talking about the inverse function, we are swapping, right? We are swapping the x and the y. So now for the inverse function, so this is for the function, for the inverse function, what will happen is this guy, this one, will be swapped with that one. So in other words, the relationship will not change. Okay, it will still be 1 to 1. Still, it will be still be 1 to 1. Okay, so for a straight line, we know for a straight line graph, the function, the graph itself is a function, and the inverse is a function as well. Okay, hopefully that makes sense. And then we can consider a different case. Okay, let's say we have a situation of a parabola. Remember that the parabola we established previously, or we concluded that the relationship that is associated with the parabola, or the relationship that describes a parabola, is the relationship of many to one, many to 1. Okay, so this is a parabola. Okay, this is a parabola, and we know that a many to one relationship is still a function. Okay, now what will happen if we look for the inverse of this graph, the inverse of a parabola? Now the inverse, what do? We swap them, right? So basically this is for the function, and then for the inverse function, what will happen is that it will become a 1 to main. Okay, a 1 to main, because what will happen is this y will be swapped with this x, and then now it will become 1 to main. Okay, now we know that a 1 to many relationship is That relationship whereby there is a sharing of x values. You remember when we were talking about the circle in our previous session, when we were looking at the circle, we saw that a circle is associated with this type of relationship, one to many, whereby one x value is shared by more than one y value. So they are sharing x values, and that is not allowed. And because of that is not allowed, because that is not allowed, um, we are we are saying that this guy is not a function. So we conclude and say that the inverse of a parabola is not a function. Okay, not a function. It is not a function. Okay.